We are using a bird dataset to do our bird classification, and this is our dataset. First is the bounding box. It included the name of the picture and the bounding boxes. You can see that. And then it is the classes with the label and the label name. Like the first 22 is the first layer, and from the 23 is the next layer. It is in all 5 layers, and we'll get to that in the future. And this is the hierarchy. The first 22 is divided into the 0 layer, and the 23 to 50 is the next layer. And this is the hierarchy look like. This is the name and the 555 labels. And these are the path to the picture and the picture name. And these are the images that we are going to use. We wrote a script to divide, like, the match the 3rd layer and to the 4th and 5th layer and get a TXT like this. So from the picture, we can see that the 3rd layer is divided into the 5th layer starting from the 251 and the 5th layer starting from 746. This is the script we wrote for the matching. And then we get the TXT like this with the label name and then the next labels. In order to do the object detection, then we need to put the bounding box in the sizes and move all the pictures into one folder so that we can use for the object detection. And then we wrote a script to put all the different name of the pictures into the same folder, which is the final picture data director. We can see from the folder that all the pictures are put in the final picture director. And this is how we get to get a TXT that match the labels and the bounding boxes and the sizes. And after the script, this is the final TXT we get, and then we put it into the CSV file. Like the first 2 is the sizes, and then the names. And this is the labels with the name and all the bounding boxes.
So with the Excel file that we got from the previous step, we can separate them into test labels, test files, and training files. This is the Jupyter notebook that we created to do this. So as you can see, we split them into 2 different groups. And then the next step will be to generate the labels for our dataset, and then as you can see, we use R to generate these labels. So with the labels, we can now edit our TF record file. This is how we convert Excel files into record files that Google Cloud can recognize. So these are the codes that we wrote. With the 2 record files, here's a overview of the Excel file that we got. So with the record files, we can now start our training as soon as we do the configuration for the clouds. And this is what we did for the configuration. It's a very simple configuration that we got from the internet. It's basically a standard configuration. So in the cloud folder, we put in the label map. This is one that we created using our R code. It has basically the mapping of the whole data set. As you can see here, that we put into the 3 model files. These are the pre-trained SSD exception v2 files that are based on the Cocoa dataset. This is the configuration that we use for our file. Google Cloud has to read this configuration and train according to it. We stop around 200,000 steps. That's what we predefined, but we stop earlier than that. These are the commands that we use to train. So you can see there are 2 separate commands that we do it for detection and evaluation. So after submitting the jobs, we can see the jobs here at the Google Cloud platform. And this is the detection that ran for a whole day. This is an overview of what Google Cloud did. We also have an evaluation file that ran for a shorter time, where we ran for around half a day. Since Google Cloud deletes all the log files after a while, so we can only demonstrate this screenshot we took. As you can see here, this is what we got when we were doing the training. Here we can see the accuracy and the total loss at around 100K steps. Everything is pretty much stabilized, and we can't gain any more improvements, so we stopped the process.
The whole backend is based on AWS with Flask and TensorFlow running on it, and the Flask application is like this with the configuration Python file and the template that includes the HTML, JavaScript, and CSS. So now we are going to visualize our project so that common people can use. And this is the Flask backend that we wrote for doing the backend stuffs. All of it is based on Flask and also the TensorFlow. This is the index that we will get, and we have the upload function so that people can upload their images from their local computer. And they can also use it by their mobile phone. And this is the model that we have, and the number of classes is 555 that we have. And this is the graph that the model that we used, that we trained. From these lines that we can load the images into the NumPy array for the TensorFlow to do the recognition. And also, after the loading the NumPy array and get to what we want, we can have the 3 highest scores for us to do the classification. And also, after that, we will output our results onto the images, onto the pages that we have. And the goal of it is we created a website for it. And this is the image path that we have so that we can get for the common people so that they can display the result onto the page. And the port we are using is 5000, which is based on the Amazon AWS. Now let's run our script. You can see from it that it is running on the 5000 port. And here, this is the HTTP post and what we get. Now let's choose the file. So we can go to the Google and download the picture. And let's do the yellow rumped wobbler. And download the image. So now we have got the images. So we choose the file that we just downloaded. And we upload it onto our AWS server. So now here it is uploading. And we can see from the back end that it is storing our file into our AWS server for the TensorFlow to recognize. Maybe the images we downloaded is too large, so it took some time for us to upload. And now it is starting to run the TensorFlow on the back end, and takes quite a while because as we have more than 500 labels to label, so it took quite a while for us to get to the result. And now you can see that we have got the result, and it is returning that the 3 highest possible species that these images can be. So from that, we can see that it is the yellow rumped warbler that we downloaded from the Google. And this is the right species that we want. And this is, we can see that it is running on its AWS server. So now let's go back to see the HTML, JavaScript, and CSS files. So now we are going to the statistics folder because this is what the Flask want, and these are the files that we have. And the images we name that tutorial.png is the file that we get from the result of the TensorFlow. Let's see what it is. So this is the result that we get from the running the TensorFlow, and then we put it back and push it onto the index HTML so that we can see the file. And let's go to the templates folder for displaying of the HTML. Let's see the HTML file, and it is using JavaScript, and it is also always based on the Flask. So what we have on the AWS server is using by two curly bracket, like in the string variable, so that we can put it onto our website that we get. And so that's the end of our video. Thanks for watching.